Hi there. Now I'm going to demonstrate our application, which is a event-driven Bayesian data pipeline to harvest the data, process data, and store the data into the Elasticsearch. First, I'm going to introduce our Bayesian environments. Let's run Bayesian environment list. As you can see, there are three environments. First one is the Node.js. You use the built-in Bayesian Node.js image, and the last list two is the Python image. We use the image from our customized Python environment image from the Docker Hub. This is our Docker page for these two Python images. Now let's get started with the build the Bayesian pipeline. Let's run a few SSH. Okay, all down. Show you the Bayesian package list. As you can see, this is all the required package for to build the Bayesian function. Let's go to see the build Bayesian list. As you can see, we got all harvest Bayesian function and then AQ function and a observation function. Okay, before we start to run the harvest function, I will first run the Grafana and Redis GUI. Okay, let's go back and run the harvest function. Okay. Okay, all done. Let's go to Redis GUI to check the message queue. As you can see, there's a student election topic to start harvest data from the harvest function. Let's refresh. As you can see, it has been changed to the topic observations by the Mastodon Bayesian processor function. And let's keep refresh. Okay, now it has been consumed by the consumer in our application. It has been inserted into the Elasticsearch. Refresh. Okay, and there's a demo in text has been created in the Elasticsearch. Let's go to the data view to check. Yeah. As you can see, there are 1,000 data in this in text and all from the Mastodon. Okay, this works. Now that's the end of my demonstration for the data pipeline in Bayesian. And next, our group member will introduce the front end and the data visualization.
Now I'm going to show how we use Python and Elasticsearch to search and export data. We're now in a Jupyter notebook, and first we define a fast API service with an endpoint that searches by author name. So for example, we can have a name like the book Muse one, and by this function we can search all the author's information in JSON format, and after that, after we run this, it sends a match query to Elasticsearch and returns the result. Next, we define a script that, not script, code, self code that can export all documents using the Scroll API. So it loads previously saved IDs, avoids duplicates, and save in batches like batch1.json. And we can have a try. So the progress is showing in the output, and its growth continues until all docs are processed. As we got like millions of Mastodon data, it will last a while. it took like 4 minutes to get all the data, and finally we merged all the JSON files to one for further research. Now the Jupyter Notebook, we run it on the Kaggle. It offers free GPU resources. In this notebook, we analyze the posts we get from the previous steps, and we use topic modeling, sentiment analysis, and have a lot of visualizations. Firstly, we pre-process the data and compute the sentence embeddings. We first read the JSON, and we extract. We do a little engagement score to filter useful posts. So in this case, we just filter 50% of the data. Then we do embedding. We use a sentence transformer model to make the text into vectors for further research. So it won't last a long time since we are not using a light model, and we filter half of our data. Then we using a model called BirdTopic. BirdTopic can automatically extract topics from the dense text and after embedding, yes. So for every month we need to fit a BirdTopic model and extract the 10 most popular ones, record it. It's a long step, and after that we get this. This is my favorite one. We can see it can dynamically show the trend of different topics, how the topics are shaped, and what's the most common ones. We can see like COVID and food, we see a lot. So this is really cool. And yes, we print plots, stable plots, just information from the BirdTopic ones. And then we do some sentiment analysis. We're using a library called TextBlob, and we can see after we compute the monthly sentiment trends, we can see the sentiment peaked at in the late of 2020 and gradually declined to today. Yes. Then we do some statistics with the emojis and compare them with sentiment trends across in time, so we can find like smiling face. This kind of emotional emoji is highly have the same trend with these ones, with the sentiment trends. Then what we do is we build a topic network, and now we can look at this visualization. Each node of these ones are the topic we extract. For example, this one is photography, and this one is nature. This blue one is wildlife. They are connected and share same color. This means they are strongly connected. So yes, we can see nature, photography, yeah, and wildlife are close topics. So we can find a lot of interest outcomes from this plot. This is my favorite. So this share same color means they have really similar attributes. And after that, we do a Sankey plot. It shows how some topics and their trend to with sentiment. So these three ones are trend to positive sentiment. And this is another stream graph, looks cool, with the top 10 topics over time. You can see we do not have a lot of data before 2023, as Mastodon is a very new community. Then we selected a specific topic, we isolate posts about Ukraine and Gaza, and we compare their monthly volume and sentiment. Uh, yes, then we can see Gaza related posts tend to be slightly more positive overall, but both stay close to neutral. Yeah, like close to zero. And from these violin plots, we can see it help realize sentiment distribution and shifts over time. Yes, so these two topics really share the similar trend in sentiment. So this is just a few visualizations. This is all of our works. Thank you for watching.